We're gonna do the following problems using K-maps. So we have the first one. We have to find sum of products and product of sums for the following function. Okay. So this is how a K-map looks like. So we will have the input be represented like this. We have 0, 1, 0, 0, 0, 1, 1, 1, and 1, 0. And these slots are represented by a number when you combine these. So this one will be 0, this one will be 1, this one will be 3, this one will be 2. So then this 4, 5, 6, and 7. Okay, so these are the slots it's going to be true at. So it's going to be 1 here, 1 here, 1 here, and 1 here. And then the rest will just be 0. So now we can group them in 2 to the power of a number. So we can group them like this and this. So that's allowed. If there was another one here, then we can group them like this instead. Or if there was like ones like this, we can group them like this. This is also allowed. Or we can group them in groups of 4s in this format. So if they were like this, we can group them like this. But never group them like something like this. This is not allowed. Okay, so we'll group them like this for now. So the value of this one, so we have to see which x's are changing. So we see x1 changes from 0 to 1 as we move down, so we can include it, but x2 and x3, they remain the same. x2 is represented by 0, so it has to be knotted. And x3 is represented by 1, so we just leave it as it is. This one, x1 doesn't change, but it's represented by 0, so it's knotted. x2 remains the same. So the output will be x1 naught x2 plus x2 naught x3. Now, this is for sum of products. Now we have to find the one for product of sums. So this is what we do. We instead of circling the ones, we circle the zeros. So this one is actually different. If it's represented by a 0, we actually don't knot it. But if it's represented by a 1, we knot it. So x1 changes, we don't include it, but x2 and x3 don't change. But for product of sums, we have to add them. Okay, so x1 doesn't change for this one, but it's represented by 1, so we knot it. Plus x2 naught, because x2 doesn't change. And our output will be x2 plus x3 times x1 naught plus x2 naught. Okay, so that's first problem solved. Second one is pretty much asking the same thing, but we have this d. This d is supposed to represent a don't care. And I'll explain to you what that means. Okay, so say we have the K-map again. Okay, so these are obviously the values that it's going to be true at. So 1 here, 1 here, and 1 here. Now, these are don't care values, so we put a D to represent them. So pretty much if a don't care value is next to a 1, you can circle it with it. However, if a don't care value is alone, don't circle it because it's going to just be extra steps you're adding to yourself. So we can group them like this. So this one, x1 doesn't change, and x2 doesn't change. But x2 is represented by 0, so we knot it. x1 doesn't change, x3 doesn't change. And this one, x1 changes, but x2 doesn't change, and x3 doesn't change. So our output would be x1 x2 naught plus x2 naught x3 plus x1 x3. Now remember, this is for sum of products. Now we have to do one for product of sums. So we instead circle the zeros. So we can circle like this, and then obviously include this one. So for this one, it's going to be x2 plus x. Hold on, let me change color. x2 plus x3. But since this is product of sums, if it's represented by 1, it has to be knotted. So now for this one, it's x1 plus x3. Okay, because when we move from here to here, x3 remains the same. And the last one is this one. It's x1 plus x2 naught. Okay, so it's going to be x1 plus x3, x1 plus x2 naught, x2 naught plus x3. Okay, so that's another one solved. The last one is a really long one. So we have this 4 input K-map, and the pi symbol represents a product of sums. Okay, so since we have a 4 input, we need a 4 input K-map. So we have x1, x2, x3, x4. So it's going to look something like this. Okay, so this is 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 2, 3, 4, 5, 6, 7. 8 is down here actually. 9, 10, 11, 12, 13, 14, and 15. So these are, since this is a product of sums, these are the values where it's going to be false, so it's going to be 0. If it was a sum of products, so lowercase m here, then these will be the regions that will be true. So we will put a 1 here, 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 a 1 here. Where else? A 1 here, a 1 here, and a 1 here. Did I get everything? No, nothing missing? Oh wait, there's also 1 here. Okay, good catch. And the rest would just be zeros. Okay? But in product of in sum of product, sorry, in product of sum, it's everything's flipped. So this would be 0, 0, 0. This would be 1. This would be 1, 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, and I think that's it. Let me double check. I shouldn't been flipping them while I was, but hold on, let me just check. Okay, yeah, I think that should be good. So pretty much we just group them. So we can group them in different ways. We can group all of these together. We can group all of these ones. How else? We can group like these two. We can group these ones. Oh, wait, I just realized I made a small mistake. There should be a 2. Sorry, there should be like a 2 somewhere here. So there should be a 0 here. My apologies. So we would have to incorporate that alone too there as well. So how we can do that is by doing it like this. Okay? And then one more like this. Okay, let's start solving. So this one is going to be x3 and x4 are the only ones that don't change. For this one, x1 doesn't change, x2 doesn't change, x3 doesn't change. Okay, now for this one, x3 doesn't change, and x2 doesn't change. Sorry, x1 doesn't change. Now for this one, x4 doesn't change, and x1 and x2 doesn't change. For this one, x3 doesn't change, x4 doesn't change. So sorry, x3 not. It's x3 not. Then x4, and x1 doesn't change. And then the last one, the one that's broken up into two, again, x3 not plus x4, and then x2 doesn't change. Okay, and then your final answer is you just